Let's look at plotting a trig function using a spreadsheet instead of Desmos. Desmos is really easy, but the spreadsheet gives you some other controls as well. We're going to put in the sine function of an angle. So if you click into an area of the spreadsheet and you just type in sine A4, it'll automatically take the sine of whatever's in this spot here. And you see it repeats up there. So once you've hit enter in your office cell, when you click into it, you won't see the formula anymore. You have to look up here. The question is, what is this plotting? We know 0 degrees, 0 radians will give you 0 on a sine function. But 360 should also give us 0. So if I type in 360, that's not 0. So this is obviously in radians. And you can double check by taking pi, times it by 2, equals, edit, copy, and go in here, paste it in. Get 0. So it's doing pi radians for a half circle, 2 pi radians for a full circle. Let's divide this down by 100, and there's a reason for this. Decimal 0.6. All right, quick and easy way of turning it to 100th of a degree. What if I want to step up by that amount? And I kind of goofed here. I meant to put it there. So I'm going to put 0 back in here. So here's my first step. I've moved up by 100th of a circle. This is 3.6 degrees because a full circle is 2 pi. If I divide it by 100, 100th of 360 is 3.6. If I take this cell here, grab that little square, drag down, notice the number changed. I'll click into that cell. There's the new formula. The formula updated to the 5th one. The formula here referred to cell A4, and by copying the formula down a cell, it assumes you want to apply the formula down the next cell as well. What about increasing the angle? Am I going to have to manually enter 1/100th of 2 pi all the way down? No. If the sequence is predictable, like it's going up by an even number, I select the 2 columns, and I drag down, and you can see it's leaping up by 0.06 each time. So if I want to get 100 values, what I have to do, the formula I only need to select it once and drag it down. But if I want a sequence of numbers to be replicated, you have to get at least 2 numbers for the computer to see the pattern. And we'll drag all the way down to 100, and it should fill in for us all these values. All I need to do now is capture these last ones here. Now I've got them all, and I'm going to click Chart. And I'm going to go in here, click. And look what it's done. It's created a nice little graph for us. It's already even borrowed the titles off the top of that column. Yeah. When we get this plot, it will have a tendency to want to do line charts, more business. So very often in science, we want to see scatter plots of the actual dots. Here, it's not that important to see, but otherwise it's going to just do straight line connection, and that can really mess up your experiment data. So I'm going to leave it in line for this one. And then we're going to try adding noise. So this column here is going to be some noise added to it. And I've already put in the starting formula. Equals rand times B4. And what this means is it's going to take whatever's in B4 and multiply it by a random number. That random number will be between 0 and 1. So this number here could be multiplied by any value from 0 to 1, and it will create a random number variation on that. And this is a quick and easy way of adding noise to an experiment. To get that in here, we will add a series. So I'm going to go in here and add series right here. Now you notice the pattern. You have to go like this and then do it over here. It can be a pain sometimes to figure out one spreadsheet from another. And there's our random data added in there. You can still see it's following the original curve, but now you see this random noise added on top. Now that's a huge noise signal. What if I wanted to change the formula so the noise signal was much smaller? Well, instead of multiplying by the random number times what's in B4, perhaps we could just take that and shrink it down a little bit, and we'll go 0.1 times, and then we'll make the random noise a little bit suppressed, and we'll add it to the signal in B4 as well, plus B4. And now it should be doing that. Now, did it update all the others? No, it did not. See? It only changed that first equation, so we have to drag and drop it in here, and we should see a new randomizing of the values. Now that's looking like a signal with some noise. And next we'll play in Audacity and see what we can do by simulating noise. So let's say there's an experiment where you want to put in some variation to simulate reality. Like you're doing modeling of the climate, and this is sunlight intensity over the course of the year, but you know clouds interfere with that. So you take your scientific model and then you create some noise on the data, and you play with this noise to see what it does to your final answer. And that's what we do in simulations. So this is a really early example of how you can create simulated data sets and experiment with noise. And now we'll listen to what that noise sounds like. Go into Audacity, and I want you to click on Generate and Tone. Pick the sine wave and let it auto-generate at 440, 1760, it doesn't matter. Now to zoom in, we'll zoom in on this tone by going to View, Zoom In, and you can see it says Control 1. So if you press Control 1 repeatedly, you can zoom in till we actually see the waveform. And there's the sine wave it generated for us. Now what we're going to do is create a noise track. So you go to Track, Add New, Mono Track. And we have a new track that we must select, so what we do doesn't apply to both tracks. So now I've got it selected. I go to Generate, Noise, and it's going to say white noise, and we click on that. And it'll zoom out again. So again, Control 1 repeatedly pressed will zoom us in, and we'll see the waveforms. Now we're going to adjust the gain before we add these two waves up. So if we go in here to the volume level, you see it says 0 dB. 0 dB is your normal balanced. We'll take this one and slide it to -13. And now we can add the waves up. You can play them directly to hear what the noise together sounds like, but we can actually mix these tracks. That's the noise by itself. If you go to Track, Mix and Render to New Track, it will create the combination. But it tells you you got to select everything first. And to select everything, Control A will do it. Now you've selected both tracks. You go to Mix and Render to New Track, and there is the result of the sine wave being added to noise, similar to what you created on the spreadsheet. I'm getting rid of it, and I'm going to change the balance. I'm going to put the gain to about 0 on the noise, and I'm going to reduce the signal to -10 dB. We'll mix and render to a new track. And now we see the sine wave has nearly disappeared into noise. Hit solo. Did with the plotting program, you now just did in practice with Audacity.